Namely, we've been doing a lot of things related to sensors, so sensor developments. And I think there's a lot of opportunities for developing new types of sensors. Okay, as I mentioned before, I have created a startup company predominantly doing sensors for hydrocarbon leak detection. I'm going to briefly talk about. And right now they're doing okay. I think they have over 6 or 7 people working in Edmonton, and I think they raised millions of dollars from venture capitalists and angels and whatnot. So anyway, my name is Simon Park. I've been at the University of Calgary for past 17 years. And my lab name is Multifunction Engineering Dynamics Automation Lab. And today, I'm going to talk about sensors and monitoring, development of new novel sensors and applications. So what we do, we try to imagine and try to come up with some problems. And we try to solve those problems through innovations. And we try to make something useful. Okay? And we do something from very small scale, such as working with the carbon nanotubes here. And we also use AFM, atomic force microscope, to something very big. So I also work with a lot of pipeline things. Okay. So this is my lab. This is a picture a few years ago. So we do research on sensors and monitoring, advanced manufacturing, and pipeline engineering. And some of these, we also do a fair bit of IoT aspects as well as artificial intelligence. So some of my students are working on CNN, LSTM, AMPHIS, ANN, and so on and so forth. So we have a very big group. Right now, I have 6 labs, and our labs sort of intersect with not only mechanical engineering, but electrical engineering as well as chemical engineering. So some of the content seems fairly chemical to you, but I mean, let's just go over here. So today, I'm going to talk about hybrid copper nano composite inks using IPL. IPL stands for intense pulsed light. Okay, have you heard of flexible circuits before? Yeah. Okay. So right now we are developing a new process making flexible circuits, and we developed a special ink, and we print these things onto flexible PET substrates. And by doing that, we can make sensors or electrical tracks. Some of the sensors we're developing, strain and force sensors. And the second one is hydrocarbon leak detection sensor. This is the technology we developed at the University of Calgary. And later we founded a company, and the company is in Edmonton doing good. So I'm going to briefly talk about those. And lastly, maybe just touch on aluminum batteries. Okay. So first, I'm going to talk about hybrid copper conductive ink for flexible electrodes under intense pulsed light. Okay. People talk about this as a printed electronics. So we are trying to print the electronics onto substrates. And it's very similar to printing newspapers and so on and so forth. This one here is a screen printer. It's the same kind of machine that you use for making t-shirts. Okay. And this one here is a bunch of capacitors, and this is a flash system that we have. Literally, we use a flash. It's the xenon flash, and we use these to make sort of this kind of patterns. And this one here is a strain gauge. Many of you heard Industry 4.0, okay? Digital manufacturing, smart factories, cyber physical systems. So from first where, Watt has come up with the steam engine, and Model T, conveyor belt, and computers. And this is where we are, cyber physical system, or known as Industry 4.0. What is Industry 4.0? It is, big chunk is actually getting the data from sensors, and some of these sensors go into clouds and do analytics and then come up with a better solution. The bottom right, this picture here is a modern vehicle. And these are all the different types of sensors. Okay, so modern vehicles have lots and lots of sensors. And people looked at it. The cars today versus cars 15 years ago, they're literally 15 times more sensors, and it's only going to go up. Especially some of these vehicles will become autonomous. Okay. So what do we need? We need sensors that are accurate and reliable, and we call these as a pervasive sensing, meaning that you have lots and lots of sensors, and these communicate, and then get the data, and then come up with the better solutions. In case for the cars, you want the optimal fuel economy, optimal power, and the safety. So this is a printed electronics. Okay, you've probably seen these flexible screen, flexible sensors, and whatnot. So the printed electronics, some of the applications include display, lighting, sensing, energy harvesting, and smart systems. The future lies on what's known as a roll-to-roll printing. This is how newspapers were printed before. And instead of typical ink, we put conductive ink, and it becomes as a unique smart system. Okay. So now the question is, what kind of ink do we have to make? So these are three candidates: copper, silver, and gold. If you look at the price of gold, actually right now it's really expensive, probably over $50,000 per kilogram. And silver and copper, the orders of magnitude smaller, okay? Yet, if you look at the Barker resistivity, this electrical resistivity, they're very similar. Okay? And people may ask, why not use copper for the air tracks and whatnot? They're very cheap, yet you have good electrical resistivity. Well, the problem is known as oxidation. Okay, when you make copper, coppers can get easily oxidized. So we spent many years trying to solve this thing. And there we came up with the special formula. We call these as a recipe. We call this as a hybrid copper and silver. So we mix copper with the silver salt, and through flashlight, we can make fairly decent copper tracks. Okay. So fair bit of chemistry, it's called a galvanic reaction. Just to give you a comparison, this is a copper alone versus this is our ink copper silver. So what happened with the silver is coating the outer layer of copper particles. So at high temperature, this is sort of the expediting the oxidation process. After 40 minutes, because of the oxidation, it's not conductive. Whereas copper silver, we can have this thing for many hours to minimize oxidation. Anyway, so we developed these inks a number of years ago. And you may ask, how does this work? I'm not sure. I'm going to show a video. I'm not sure whether you can hear the voice. Okay, okay, it doesn't work, but let me explain. So this is my PhD student, and this is my postdoc. And it's explaining how this IPL sintering works. Without the actual heat, because right now we are using very tiny nanoscale powders. They're not conductive. And we have to go through what's known as a sintering process. It's below the melting temperature, but you have a necking so that you have good electrical conductivity. But what we are doing is we are using these are known as the masks, okay? And these masks are made out of steel, and these are etched away. And what we are trying to do is we just want to shine the light through wherever that's etched. And these are the patterns for different strain gauges, okay, measuring strain. And this is the flash, okay? And one flash, boom, and the light penetrates through, and this is what you have. And if you measure the area, it's dark, it's overloaded, it's not conductive. And when you measure the area when it's exposed, you have a fairly decent conduction. Okay, that's how the printed electronics work. And this is a demonstration of screen printing. So here, we are using screen printer. We are putting very thin, flexible plastic sheet. And this is nothing more than a t-shirt making screen printing machine. And instead, we put our own ink. And when we take it out, it's kind of dark brownish color. It's not conductive. What we do is we bring this thing to flash, and we go through sintering. And if we sinter, now we have nice, shiny copper color. And you can see that it's fairly conductive. Okay? So we use these things for making mass production of different circuits and sensors and whatnot. So specifically, I'm going to talk about a few different applications of different sensors. So this is force and strain sensing. And in this particular case, we are using polymer nanocomposites. So we try to measure force, and if you can measure force, you can do many different things. Okay, so these are different. This is a CNC machine we have in our lab. This particular CNC machine, actually, we are using these tiny tools. This is probably a few hundred micrometers. Your hair, thickness of your hair is about 100 micrometers. So we use tools that's slightly bigger than thickness of your hair. One of the big problems is that these are very fragile. So you have to understand force, and then you have to optimize the process. So these are common type of sensors, strain gauge sensors. This is a piezoelectric load cell, or the table dynamometer. This thing here measures the cutting forces. And this thing here costs, I usually joke around with my students, this is a price of a nice BMWs or Mercedes-Benz. That's how expensive it is, okay? And this is a laser interferometers. Okay, using laser with this beam splitters, and then you have a photodiode and a capacitive sensor. The bottom line is that the existing sensing system for these applications are very expensive, okay? And they have a limited frequency bandwidth. So we thought that, can we make a sensor that we can spray paint onto different surfaces, okay? And we use what's known as piezo-resistive and piezoelectric capabilities. And we are using both of these through sensor fusion, okay? Piezo-resistive provides a low frequency, and piezoelectric provides high frequency. So by combining these two, we can measure both high as well as a low frequency. And because of the spray paint, we can apply these things to any surfaces. So how does it work? This is a piezo-resistive. We put carbon nanotubes onto polymer. Carbon nanotubes are very conductive. So their electrons can travel when these carbon nanotubes touch each other. Another way of traveling is what's known as a tunneling effect. If these carbon nanotubes are close to each other, let's say about an angstrom, electrons can hop. That's known as tunneling effect. So this is the case, and if you apply a load, force, a compressive force, the distance between these fibers get closer, and you have a lot more conductive path. So when you apply force, your resistance goes down. When you apply tension, resistance go up. That's known as a piezoresistor. Piezoelectric is a sort of different phenomena. We are using polymer called the polyvinylidene difluoride. Usually it's in the alpha phase, sort of the random orientation. And when you apply pulling, you have these fibers can be oriented with the pulling direction, okay, and exhibit piezoelectric properties. Piezoelectric properties, when you apply load, you have electrons popping out, or the current pops out, or vice versa. So how are you making these sensors? So we can do compression molding. This is a 4-post compression molding, or spray painting. This is a spray paint system controlled with the CNC, or sometimes we use injection molding, making plastic parts. And depending on the process, we have different alignments of carbon nanotubes, and we sort of modify the alignments and we get different properties. So those are some of the research that we are working on. As I mentioned before, the PVDF, this is a unique polymer. When you regularly it's a random orientation, the polarity is all over, it's not quite aligned. When you apply high voltage, these fluoride chains get aligned and you exhibit piezoelectric properties. Okay? So what in our case, we apply corona charge about 15 kilovolt. So these are some of the testing equipment. This is known as potentiostat or impedance analyzer. This is the tensor tester. This is measuring the piezoelectric properties known as D33 meter. And this is dynamic mechanical analyzer, so looking at the thermomechanical properties. And this is how we pull. Okay, we apply high voltage. Okay, and this is a homemade. My students have made. These are meters, and then we apply extremely high voltage. In this particular case, about 15 kilovolt. And when we apply these high voltage, those fluoride chains can be aligned, okay, through pulling, and we can achieve fairly high piezoelectric coefficient. This is a 31.2 for this film, and we can use these as a sensor. And we did some testing for the shaker testing. So this one here exhibiting very low frequency. Right now we are moving very low. So this is a range of earthquakes and so on. And it's not very easy to make sensors that can measure very small displacement or the frequency. And as I said before, by using piezoresistive characteristics, we can measure pretty okay. Whereas the piezoelectric doesn't quite measure. The other way around, when you apply this thing at a very high frequency, piezoresistive, the bandwidth is not there, whereas the piezoelectric can measure. So what we have done is we combine these two through sensor fusion and be able to achieve fairly decent measurements, both at low frequency and high frequency. We then try to make some of the force sensors, and these are different kind of composites, okay? And I told you before, the table dynamometer that costs the same as a nice BMW, we are trying to make these things cheaper. And this is the very first prototype, and then more. And later on, we made 12 elements. Instead of $50,000, the table dyno, this one probably costed us maybe a couple $1,000 to fabricate. And when we compare with the $50,000 reference versus our sensor, as you can see, it matches it fairly good. And we're fairly happy with this. And this is sort of the static measurements, whereas the dynamic measurement, this is for the milling operations at the 3000 RPM. both the reference and our sensor exhibited fairly decent peak-to-peak forces. So we are happy and published a bunch of papers. And then we are trying to make some smart skin. Okay, in this particular case, we are putting electrodes only on the outer uh, area, and this is a sensor. We literally spray paint it, and we want to make smart skin so that we can apply this skin to many different locations and whatnot. And this is a very early preliminary testing that we have done. This is a compressive testing that we are doing. This is a sensor, and this is what you're gonna see. So we are apply compressive force. And as you can see, we can localize and we know exactly how much force or pressure you're applying. When you bring it up, it goes back to the original state. So I thought that that's a good idea. What can we do? And I and my students actually right now, that my students use this to create a startup company, student-run startup company called Make Sense. And this is sort of the early prototype. So here, it's a pressure-sensitive mat, and they're trying to market these, commercialize these. These can be flexible, and right now it's connected with the USB. So this is a pressure mat, okay? And when you apply different pressure, you can see that you have a different, characteristics. We made this thing, even using for musical instruments as well as a different pressure mat, devices. And these mats are flexible, and we are exploring different applications and trying to get some funding as well. This is sort of depending on how much force you put on, you can see different viewpoints. Okay? But these are done by students. So what we envision is we want to make these patches for machining and different industrial processes. And we apply these into a lot of different surfaces and have a high frequency and then do cloud-based processing. The next application is, this is a chemical sensor. It's known as a hydrocarbon leak detection sensor for use in pipelines. So I am my PhD student in 2010. There are a few accidents happen here. Okay, this is Kalamazoo River, and there's a few different locations and so on. In Kalamazoo River, they spilled about 819,000 gallons just to clean up. They spent 1.2 billion US dollars. We thought that, why not make sensors? That's cheap. You can apply them to different surfaces. And since then, we did a few prototyping and testing and whatnot. This is a very early, we put crude oil, and this is the sensor array. And the sensors are made out of polymers with certain carbon nanotubes and other things, okay? What happened is when hydrocarbon gets interact with the polymer, it provides different electrical properties. And this is a very first thing. The interesting thing was that when we spilled this or drilled the hole, we could see exactly how hydrocarbon was flowing onto the surface. So we thought that, wow, that's good. Can we pitch this to Innovate Calgary? So we pitched to Innovate Calgary. This is again probably about 7-8 years ago. And this is a sensor array, and we filled it with the motor oil. Motor oil is a fairly heavy, but still we can demonstrate that it is a very sensitive. So this is a flexible sensor array, and this is electrical properties. After vapor gets touched with the sensor, you can see the change of the electrical properties. And then we went back. So we pitched to Innovate Calgary. Innovate Calgary is an incubation hub. It's in the University of Calgary. And back then, they had a program called Investment for the New Startup. And we went and pitched, and they awarded $500,000 to create the startup company. And this is sort of what we envision. Now the company is doing a lot more than what I'm doing right now. I'm not directly involved with the day-to-day business operations. I'm more of a small shareholder. Anyway, this is another picture. This is we coated the surface of a pipe. This is a sensor material. This is the electrical properties. And when we drop 1 microliter of a pentane, you can see change of the electrical properties. And it's a fairly instantaneous. Okay, you can see. And pentane is a fairly volatile, so after a little while it gets dried off. And my student goes and tests a different location. Okay, the same thing. And this is all controlled by Arduinos and some multiplexers with the cables and whatnot, and we programmed a fairly complicated system here. Anyway, so right now the company is doing good, you know, and they were able to raise millions of dollars money, and then they are going after big companies, as we discuss this now. The last is a metal-air battery. So you probably know lithium-ion batteries. The lithium is scarce, and this may happen. Okay, explosions. It's caused by what's known as a thermal runaway. So even though you take out the load, the chemical reaction doesn't stop, and especially hot day, this can happen. Another downside of the battery is that lithium ions usually can operate below 0 degrees Celsius. So in winter time, efficiency is terrible. So those Tesla vehicles, they have a heater so that they heat up above 0 degrees Celsius so that batteries can operate in an efficient manner. So it's not very efficient because you have the heat. So we looked at the different types of batteries. This is sort of the weight, and this is size. Most ideal things are probably in this corner, and this is what, you know, typical lead acid. When we looked at the thing, lithium air, and this is probably the most ideal thing, but when we did some literature survey, this is very explosive. So we said, it's not good. Then we looked at aluminum air. Aluminum, I said, wow, that's cheap. Can we use aluminum air for batteries? And we looked at the thing, it has a very high density, okay, dense density of energy. And we looked at the chemical reaction, it's fairly doable. So we did a bunch of, you know, treatments. This is a surface treatment, making this surface into here so that you have a lot more reactions. And here is, we are redecorating carbon nanotubes into gold particles and iron oxide so that we can align them. And this is what we have. This is the battery pouch, and this is the light. And you can bend it, okay? And you can do all kinds of different things and still be able to do. The reason we developed this battery is so that whenever we develop wearable technologies, you know, your batteries also have to be wearable. So this is what we developed. This is based on aluminum foil, and this is the aluminum foil that we procure from Walmart, and then this is what we made. Okay. Anyway, I talked a lot of different things and so on and so forth. In terms of finding good jobs, okay, just in my experience. Experience is very important. Prior experience. It'd be nicer if you have company experience, but it's not easy. It's catch-22. Many young people don't have that experience. So some of the suggestions: volunteer. Okay, volunteer different companies, different professors and whatnot, get involved. The people that I usually hire for internship are people who have very good programming abilities, as well as people who dealt with Arduinos, Raspberry Pi, actually develop something. Whenever I interview, especially from Waterloo, some people actually do have this sort of portfolio. These are some of the things I designed, developed, fabricated, controlled, and they even show videos. I really like that. Okay. So if you don't have these company experiences, whatnot, involve with the clubs and develop something. Okay? Develop something. And put those things, put into videos and pictures and whatnot, and put it along with your CVs. Okay? That distinguish you from other people. Other things, entrepreneurship. I know it sounds very futuristic. It's not for you, but anybody can be an entrepreneur. Okay. As I mentioned before, I created a number of companies before, and very early stage we thought that the technology is very important, but that's not the case. For entrepreneurship, business is important. You have to sell products. Okay. In order to sell products, you have to develop people are willing to pay. Okay. That's very important. You develop amazing things, amazing robots, but nobody wants it, then what's the point? So you have to have your ears open and talk to many, many, many people. Try to have a mentor who can guide you. Okay. Try to have a friends or networks. Okay? And these people will guide you through to find good jobs. Working for companies, they find, so I'll give an example, a student actually told me that when he applied to one job, okay, it was a newspaper, job. He got the position, but the fellow who was interviewing, he was saying that they received more than 2,000 resumes, and they are looking for only a couple of people. So I asked him, what made you different? Well, for that student, actually, he already had a science background and mechanical engineering background with the many years of experience. Okay, well, that's the competition like right now. Okay, that's the competition. You have to stand out, and if you don't have experience, it's very challenging. Okay, so go out there, talk to people. Okay, volunteer, learn. Okay, there's many different things you can do. Those of you who are also interested in graduate studies, okay, not only me, but also many other professors are always looking for good people. I always look for good people because for some of the things that what we are trying to do, I want to be the best in the world for whatever we are doing. And in order to be the best, I have to hire the best students, and it's always a challenging, but that's what it is. Okay. Anyway, I'm going to conclude the presentation here, and I'd like to answer any questions you may have. So I'm going to stop the presentation. Feel free to ask any question.
Hey, thank you so much. That was so interesting. I just have a few questions. So do you ever usually hire fresh graduates, or do you usually go for uh, students with experience or internships?
So for company point of view, so there are two different things. At the university, I usually hire graduate students, okay? And in order to hire, not only that I'm looking for good experience and so on and so forth, the chemistry has to be there. I like to work with the people who I like, easygoing, okay? Not so picky and not so stubborn and so on and so forth. And usually whenever I interview, I try to find these things. When you look for jobs, the first thing when you interview, they were asking is, what's your experience? Okay. Nowadays, whenever I interview so many students, okay, whether it's a summer internship position, co-ops and graduate students and whatnot. And I've changed my sort of interview format because most of you probably looked at the internet, what kind of questions or, that, you'd be expecting. So those questions, people are all prepared and so on. I'm a hard worker, I'm a fast learner, I'm independent, and then I've done this and that and whatnot. Those kind of questions actually, it's just waste of time. Rather, I try to ask questions that's sort of impromptu. Okay, say for example, Kareem, what's your unique experience? Tell me about it. And what have you learned from those experiences? Something very different. Okay, these are what I ask. The reason I'm trying to ask these kind of things is I want to develop sort of thinking, something different, something that you haven't prepared. Okay, and when you can answer those things properly, I have a lot more confidence. Okay, for students like you, what kind of question you should ask? So a very common question that you guys should ask to employer is, Dr. Park, for your position, who will be most ideal candidate? Can you give us an example and whatnot? Okay. And I would say, so and so who has done this and that and that and this, you can perhaps can grasp culture, okay? Culture. And whether you can work with this person or not. Young people try to go on the easy things nowadays, okay? Even my kids, they love games and they became professional gamers. But whenever I tell to young people, go for hard stuff, go for hard. The reason I always tell this to young people is that whenever you try to do hard stuff, okay, usually competition is a lot smaller. And it's easy to become the best in the world, okay? And if you become the best in the world, you have an option to choose what you want, okay? Instead of following. Of course, as I said, it takes a lot of efforts, okay, hard work, but then have open-minded and have many mentors and friends who can guide you through, okay? And these things are important, in my opinion, to find good jobs. Um, Most of my graduate students who do find good jobs are actually, they find the very decent jobs fairly quickly. The reasoning is um, they find jobs through my other former students, okay? Yeah, because they know what they went through. They want to hire somebody, people who are like them, and then whenever there's a position, they look for. Nowadays, actually, I have companies asking, Simon, send me good people. Okay. Of course, it's not so easy to send good people because my reputation is on the line. But maybe this, my students or other people, who I can recommend, I'd be happy to recommend, for example, right? So they're always, even though it's a fairly difficult time, some companies are thriving in this economy. Some companies doing bad. Oil and gas companies doing bad. But some other companies are thriving. And you have to look for it and search. Okay.
So I just wanted to ask, bringing up like the COVID situation, how do you think us as students can improve? How can we improve ourselves? Because in like now I'm in third year, and I felt like in first year and second year, because of the situation, I was learning more. I was experiencing more of the real world, even though I was in other clubs as well. and I felt like I had hands-on experience in most of the things I worked on. But then as COVID hit, and then everything turned online, I feel like I stopped improving myself because of the situation. It's something we can control. How do you suggest? How can you give us any tips on how we can improve ourselves in different parts of the industry?
You know what? As I said before, talk to many people. Okay, ask them for their time for, or and so there's a book. There's a many books. There's one of the book called the Lean Startup. Okay, and what the book is saying is, don't try to sell anything. Rather, try to seek advice. And if you try to seek advice, usually people are a lot more acceptable. They accept different things. So despite this challenging time, I think it's now people are a lot more used to doing Zooms and have a different meetings. Like nowadays, compared to before COVID time, I have so many meetings and so many meetings and so many different opportunities. There's a lot of companies that look for future, okay? And a lot of these contacts from companies and so on and so forth is by talking to different people. So different people sort of recommends those companies to us and so on and so forth. And that's what we've been doing. And surprisingly, I have a far more projects than now than before in this COVID time. Um, so again, it's possible. Hands-on experience is important, and now it's a very challenging. That's why you may want to join the clubs and do it yourself kind of trials. As I said before, whenever I hire internship students, I want somebody who understands good programming and then work with some robotics or mechatronics, mechanical things, along with the using Arduinos or Raspberry Pis, IoTs and whatnot. And packaging is also important. So if you have done these things, good, package it, make a videos or do something so that you can wow to your friends, girlfriends, boyfriends, and also future employers. Okay. And nowadays it's so important to have videos. Okay. So even my lab, we are trying to make demos and videos. And when companies see these kind of things, they appreciate. Okay?
Sorry, out of curiosity, can you tell us more about what you built, of what your research was about, and everything you've done? Like you told me in the beginning that you made companies and you started up companies. Can you just touch on that a little bit?
Yeah,
It's
not a
out of
problem. So, I mean, I have made a number of companies. So the first company that I made it's called Direct C. And that company was started maybe 7, 8 years ago. And as I mentioned before, we went through competition. We went through Innovate Calgary, and Innovate Calgary, back then had a fair bit of money, so they invested $500,000 to create the company. $500,000. So it's a fair bit of money, right? And then we created, and then later on, we hired a professional CEO who had a lots of experience. He happened to live in Edmonton, so the company moved to Edmonton. And while we are doing this, we talked with probably hundreds of different companies, and especially pipeline companies. And now they're doing okay. They have a lot of different customers, and they teamed up with the different companies and providing service. So that's one company. The other company is a student-run company, as I mentioned before, makes sense. So this was started with myself and my PhD students. Okay? It's been fairly dormant for last few years, but recently there's a potential investor who wants some of the technologies and who wants to work with. So we've been extremely busy trying to address. So right now we've been very busy making demos and prototypes. Okay. And yeah, so if we do get the investments, then you know, the investment is coming from overseas companies. So I just somehow I found out the company and then I talked to them and we have regular Zoom meetings and they like us and so that's how these things work actually. And nowadays, it doesn't have to be Calgary, right? Zoom meetings, you can do all of the work and seek the devices and talk to them and see, what kind of challenges he or she has. And then you simply provide some of your potential solutions. And in this case, um, they sort of like what we are doing. And I think it's, again, we are chit chatting, but they're fairly serious on the investment. So investment is one thing. You just, money is good, but the other side is that it's a lot of headaches because you have to deliver. And so I'm not sure. We'll see. It's these are two-edged swords. It's you try to bring money, and then same time you have to deliver. And I tell to my students, when you work with the companies, their deadline is not today or tomorrow. Their deadline is usually yesterday. So you have to be very agile and be able to deliver things in fast manner. Yeah, in companies usually that's the case. They want things to be done yesterday. Yeah, not today.
So I have a question. So as you were starting the companies, was it tough to start from, obviously you started from a small business, if you started small and you became bigger as more investors came in, right? How was to get to businesses coming in and trying to invest? Was it tough? Did it take a while?
Yeah, it took many years actually for the direct C. As I mentioned before, we met probably hundreds of companies and was sort of it was okay, but nobody really wanted to pay money. And we hired a professional CEO and so on and so forth. As I mentioned before, what is the most important aspect of companies' success? It is a sales, okay, not the technology, okay. And you listen to them, what kind of problems they have and how you're going to address these things. So last maybe 2 years, the company is doing good because they have professional sales people. The CEO and the COO are actually traveling all over the world and demonstrating, bring the sensors and demoing and so on and so forth. It's all relationship too. So your reputation's a relationship. It's never easy. So finding out whether people are willing to pay, that's probably the most hardest thing. Okay? And that's why I've been saying that business part is a lot more important for companies because the fact that if you don't make a sales, the company cannot exist, right? So that's hard work. It's because sometimes you have to make a cold call. Just literally pick up the phone and then you phone them. In many cases, they just hang up, right? But as I said, don't try to sell. Seek a device. In those cases, they're a lot more open-minded. Okay. Other questions from other people?
I also have another question.
Yeah,
So,
yeah. Go ahead.
so how did you start your company? Like, how did you can start a company, but how did you go through the process of starting a company? Did you just get a
So,
team
so,
and
so,
then
so starting a company is probably the easiest thing. Easiest thing. The hard part of the company is making money. So I tell you, if you own a company, you go to AMA, pay $480, and just tell them I want to start a company, and they give you a number company. That's how you start. Okay. And what you have to do is, you create the web page and then try to bring in money. And you have to, report every year for your financial stuff. So, I hire accountant to do those kind of things. It's a couple $1,000 a year. And then there's other fees associated with the government fees. So if you're willing to pay those kind of things and be able to do, that's good. Starting a company is the easiest thing. Just go walk into AMA and then just, I want to start a company, and they will help you formulate. Yeah,
And,
it's
and then I'm guessing after you started the company, the easiest part, and then you started working on your product, and then
oh
selling the
yeah,
product.
making money. It doesn't have to be a product. It's making money.
How
Sometimes you have to provide a service.
yeah.
Sometimes you make a parts or products and so on.
Did you ever get companies to hire your company to build the equipment or devices?
Yeah. We do a lot of services. It's a lot of manual labor, but the important thing is that building a relationship so that they have to trust you and you have to trust them. Okay, and these don't happen overnight. These do take some time to build a relationship. That's why I've been telling you, go out and talk to many people and build a network and the mentorships, and sometimes they will give you right guidance and whatnot. And again, talking to people doesn't cost anything. I know you have to have a thick face, which is not used to, but in order to survive in this environment, you have to. You don't have a choice. You're competing with so many different people. You know how many people are unemployed in Calgary right now? So many people, and these are a lot of experienced people, fresh graduate, and you're competing with people who have experience, right? There has to be something beyond. So that's my advice.
And obviously, from doing a good job, you get exposure as well.
Yeah, for sure. Again, if the company likes you, and then they can refer to other people, and that's how you build a relationship, and that's how you build a company,
And
right?
does the sorry, but does the net worth of the company matter? Like, let's say another company wants to hire your company. Does the net worth of your company matter to them, or
No, I think the important thing is the relationship and that whether they can trust you.
yeah,
As I said, if I hire your company, I want things to be done when yesterday. Yeah, can you do that? That can you do that? And there'll be a lot of people who'll be hiring you. Okay,
and
and that's always a challenge.
your company keeps growing, right?
Yeah, again, it's a relationship building, and it's always a trade-off, right? Because in the beginning, sometimes we do free work for companies, and then kind of try us, kind of thing, because that's how you build a relationship, and we've done that many times. Sometimes nothing comes out. Sometimes good things can come out.
Yeah,
So if you knock on the door probably 10 times, maybe you get one chance. So
yeah.
you have to knock on the door many times to many different places.
Sorry,
Don't give up.
I just have another curious question.
Yeah.
So, did any company offer to buy your company? Because yesterday
Mhm.
we had a speaker, and then he had an idea, and then he worked with a company, and they did the idea, and then they sold. The company got sold for $1 billion because of the idea he made, and then he started working for the next company, and then
Yeah. So right now, as I said, the first company that I made, Direct C, that company is making money, but it's always negative because we have too many people, and people cost a lot of money. So there are few companies or big companies in overseas are interested in our technology, and they maybe if that opportunity comes, sure, why not? But so far, I have not sold any company per se. I do have a few other sort of consulting company that I and my colleagues have formed. But yeah, again, if you try to make a company for making money, don't do it. It's not worth it. Okay, you try to have good experience and you like what you're doing, then do it. Okay, because I'm making companies not for making money, but making contacts and bringing more research money to my lab. So that's what I'm doing, and that's my motivation. Yeah. So, yeah.
thank you so much for talking about it. I think I can ask you so many more questions because
Uh,
I'm so interested, but I don't want everyone else because I think I got away from the topic a few times.
not a problem. Not a problem. As I said, um, networking relationship is a very important. Okay, and more people you talk to, they'll guide you. Okay, and how you talk to them, as I mentioned before, don't try to sell anything. Seek advice. Okay, and people are a lot more willing to provide their time. Okay, and yeah, I wish you luck for all of you. Again, it's tough time, but even though it's tough time, there's always companies and people who excel in these tough situations. And I think you guys, especially electrical engineering and mechatronics and so on and so forth, you do have a lots of opportunities compared to other people. Okay.
Thank you so much for your time. Does anyone else have any more questions?
Yeah, if you have any further questions, just send me an email, okay? And I really appreciate. And again, I just want to help out, students within the UFC and the IEEE and so on and so forth. So yeah, wish you luck. And again, my email address you can find simon.park@ucalgary.ca, and I'd be happy to provide answers.